Okay, so today we're going to be solving electrical machines for the previous grade paper. So it's question 10. It's question 10. So they say a simplified sketch of an AC generator is shown. So in this generator, you've got a coil, and then also the south and the north pole. The south and the north pole. So they say the coil of the generator rotates clockwise between the pole piece of two magnets. Okay. At a particular instant, the current in the segment PQ is the direction shown above. Okay, so let's go to the first question. The first question says, identify the magnet pole A. Only right north pole or south pole. So let's check. So the pole will be identified by the flow of current. So as you can see here, the current flows from, remember the current flows from north to south. So if the current is flowing in that direction, that means it's flowing from north pole to south pole. So A will be north pole. So check the direction of the current. Check the direction of the current. So A is the north, and this one is the south. Okay. So the answer there, okay, north pole. It's the north pole. Okay. So let's go to the next question. So the next question says the coil is rotated through 180 with the direction of the current in segment PQ be from P to Q or Q to P. Okay. So they said it's rotated 180. So you see, if it's like this, if it's straight like this, then it means now the current is flowing from P to Q like this. If it's like that, if it's like this, it means it's going from there to the P to Q. And they say it's rotated 180. So 90 degrees, it will be like this. It will be straight like this. It will be straight like this. It won't conduct because between the poles it will be like this. This is 90 degrees. Then 180 it will be straight, but now this part, if you turn it 180, this part will come this side. It will come that side. So it will be something like this. Now P, Q. Then remember the direction of the current goes like that. So you need to know if it's from P to Q or Q to P. Okay. So let's finish up this. So it will take, remember I said it will come there. It will come to this part right here. So it will take the direction of that current there. But so it will be like this. Remember, the direction of the current is from left to right, so it will flow like the same way, and then it will be something like this. So the current will flow from Q to P. It will flow from Q to P. If you rotate it 180, it will flow from Q to P. So it's Q to P. Q to P. Q to P. Then this one, I said it's the North Pole. So North Pole because the current flows from north to south. Check the direction of the current. Check the direction of the current, then it will tell you if that is flowing from north to south. And then the next question, 10.2. So 10.2, we are required to calculate the resistance of the device. So before you can calculate the resistance of the device, I need a formula sheet. It's very important. The formula sheet will help us to solve this question. So, and let's say an electrical device is connected to a generator which produces an RMS potential difference of, so this is the VRMS. Always the wall socket or AC from the wall is 220, then that will always be your VRMS. They say the maximum current passing through device is 8 amps. So we are given VRMS, which is equal to 220 volts, and Imax, which is equal to 8 amps. Okay. Then they say calculate resistance of the device. Calculate the resistance of the device. So let's look at the formula. So we are given Imax and VRMS. So let's check the formula with the resistance with R in this alternating current. So the formulas with R is this one and that one. So do you see that? And then let's check what another thing that we have. The one with R, and we've got VRMS. So we're gonna use this one because we've got VRMS and we are looking for R. So what does this mean? This means that there's no formula with Imax, you see. There's no formula with Imax. Right? There's no formula with Imax. So this tells us that we can use this formula, but we need P average. So if we decide to use this one, say PAV equals to V squared RMS over R. So if we decide to use this one, we need to know what is PAV. So let's write the formula for PAV. So PAV, in order for us to find PAV, so PAV we can find it using, look at this. Let's check the formula with Imax. Do you see that PAV we can find it? So you look at this, guys. You check. So you've got PAV, VRMS there, and IRMS. Do you know that if you take this PAV, you will be able to find, because you will be able to find this IRMS using the Imax. Okay, so if we take PAV and say PAV equals to VRMS times IRMS. You know why I'm taking this formula? The only formula that I can take is this one because I've got RMS and also I can find IRMS. So if you go to the formula sheet, IRMS equals to Imax over root 2. This is the formula. So I can be able to find that. So PAV, I can find it, but first I need to find the IRMS. Which is 8 over root 2. Then go to the calculator. So this will give you 5.67, 5.6 657 amps. Then we can go and say PAV equals to 220 times 5.657. Therefore, PAV will be equals to, so just go to the calculator, say times 220. So this is our PAV. 1244 1244.508 508. Then write what. Therefore, we'll use the initial formula with R, this one. Then in this formula, we're just gonna make R the subject of the formula. We're gonna say R equals to V squared RMS over PAV, which is equals to 220 squared divided by 1244.508. Therefore, your answer will be equals to, let's go to the calculator. So you can press AC and say 220 squared divided by answer. So this will give you 38.89. 38.89 ohms. So there's alternative formulas that you can use. There's alternative formulas that you can use. If you go to the formula sheet, you look where there's R. So there's some alternative formulas that you can use to calculate this. So you can use the VRMS formula that says Vmax, is equal to. So there's a lot of formulas that you can use, guys. Remember, you can use this formula that says Vmax equals to Imax times R. Or you can use the one that says VRMS equals to IRMS times R, meaning you still have to calculate the IRMS in this case. You know that IRMS equals to 8 over root 2. Already showed you how to get this one. Then from there, you'll say 220 equals to 8 over root 2 times R. R will be equals to will be equals to 220 divided by 5.66. We'll get the answer. You see, you get the same answer. Then also, if we decide to use this one right here, so Imax if we decide to use this one right here, you need to calculate. You know Imax, but you need to calculate. I need to calculate this one. I need to calculate the Vmax. So Vmax will be equals to this one. Vmax is equal to VRMS times VRMS times root 2. So Vmax is equals to 220 times root 2. Therefore, we can go back to that equation. Imax, we already know Imax. It's 8 over root 2. Sorry, it's 8. So you can say 220 times root 2 equals to 8 times R. R is equals to 220 root 2 times root 2 over 8. R will be equals to see, get the same answer. Get the same answer. Okay, guys. Okay, so we're gonna do the next question. So let's do the next question. So the next question says, calculate the energy consumed in 2 hours. Okay, consumed by the device in 2 hours. So you want the energy. Remember, energy is measured in joules. That's what you need to know. Energy is measured in joules. So I'm gonna go to energy. So remember, energy in 2 hours. They gave you energy and time. So go to the formula that has got energy and time. Energy, in this case, it's W. Then there's time, 2 hours. See? So this is the easiest one that we can use because we already know the p average. I already calculated the p average. Remember, this is p average. This is the p average. So I can always use this formula because I already know my values. So I'll say p average is equals to W over change in time. So I can make W subject to the formula. So change in time times p average. So what is my p average? I've already calculated from the previous question. So it helps to calculate everything. So it's sorry. So it's 1, 2, 4, 4. So it's 1, 1, 2, 4, 4.508. Then remember time, changing time, it's in 2 hours. So we need to change it to seconds. We have to change that time to seconds. So this is minutes. So to seconds, I'm gonna say so you have to change it to seconds. So seconds should be more. So they said in 2 hours. Okay. So 2 hours will be 7,200 seconds. If you change to 2 hours, it will be 7,200. See? So 160, if you say 2 times 60, it means you'll be saying in minutes. And then if you say times another 60, that's hours. So this is how you convert from hours to seconds. So if you move from this one to this one, it's minutes. So to this one, it's seconds. So 7,200 seconds. That's your time. So therefore, W will be equal to 7,200 times 1,244.508. W will be equal to times 1,244.508. It's a huge number. So you can just write 8, 8, 9, 6, 5, 4, 4. So you can just round it off. 6045. Okay. 6045. 7.6 joules. And that's how you solve that question, guys. That's how you solve it. Okay, so we're gonna do the next question, the next slide.